Please open in your learning workbook to page 180. We're now going to solve several problems involving plotting points, drawing the asymptote, and connecting those points together. All right, here's the first one. Graph g of x equals 3e to the x plus 2 power, subtract 1. To draw the graph, plot 2 points and the asymptotes, if any, then click the graph icon. Okay, great. So the first thing you want to recognize about graphing something like this is that the parent function is e to the x. So we want to start with some points that we know to be on y equals e to the x. And it says in this problem we only need 2 points. So let's think about the points that we typically associate with e to the x and pick the ones that are the easiest. Without a doubt, the values of x that are the easiest are going to be 0 and 1. Let's go ahead and plug those in. So if you replace this x with 0, then y equals e to the 0. Well, any non-zero number raised to the 0 power is 1. So we get the point 0, 1. And if we replace x with 1, we get y equals e to the 1. That's e to the first power, which is just e. So these are some really easy points that allow us to graph our parent function very quickly. So 0, 1 would be right here. And 1e, remember e is approximately 2.7, so that'd be about right here. And then we have to remember that this exponential function has its asymptote sitting right on the x-axis. So with just 2 points and a horizontal asymptote, we can create the graph of our exponential function. This is the graph of y equals e to the x. All right, so now our plan is very simple. We're going to transform this parent function into this function over here. And we have to ask ourselves, what's changed and where? All right, let's follow the order of transformation. So the first thing that we should look for is horizontal shifting. That would be adding or subtracting inside close to x. And we see that right here. This plus 2 is an example of horizontal shifting. So horizontal shifting. Remember, horizontal means it's the reverse of what you would expect. So plus 2 is actually to the left. This is horizontal shift left 2. All right, the next thing that we look for would be horizontal or vertical stretching or shrinking. And we see that we do have that in this problem as well, and that's indicated by this 3. This 3 is outside far from x, so that makes it a vertical something. We know that when it's vertical, it behaves exactly as we would expect it would. 3 is a number that's bigger than 1, so that makes this a stretch. Vertical stretch. And 3 is the number here. All right, and then the next thing we look for is reflections. We do not have any reflections. Nowhere in here is there multiplication by -1. And then the final thing that we look for is adding or subtracting outside far from x, which we do have, and this is indicative of a vertical shift. So this becomes the third thing that we do, which is a vertical shift. And we're going down 1. All right, so once we've identified all of our transformations, we just have to figure out for each one which coordinate changes and how, and then make those changes. For a horizontal shift left, it's the x coordinate that's going to change. So we're going to keep track of the changes to our coordinates here. So the y coordinates versus, the x coordinates versus the y coordinates. So for a shift to the left, think about it. If you're here at 0 and you go to the left, you end up at negative, so you're subtracting. So we're going to subtract 2 from all the x coordinates. All right, then vertical stretch. Vertical affects the y, and with a vertical stretch or shrink, it is multiplication of the y coordinate by 3. So multiply by 3. And then finally, we've got a vertical shift that also affects the y coordinate down 1. When you go down 1, the y's are getting lower, so that's subtraction. And so this is going to be subtract 1. So if we want to get our new points, to the x's, we have to subtract 2. For the y's, we have to multiply by 3 and then subtract 1. Okay, so let's go ahead and do that. Let's start with the x's. So with the x's, we have to subtract 2. Okay, so it doesn't look like I left any room for a table of points here. So I'll just squeeze one in here at the top. All right, so for the x's, we have to subtract 2. 0 subtract 2 is negative 2. I'll complete my little arrow path here so you can see where we're doing this. Okay, so 0 subtract 2 is negative 2. 1 subtract 2 is negative 1. Okay, there we go. That's our x's. Now, when it comes to the y's, we have to multiply by 3 and then subtract 1. So these guys are going to affect the y values. We're going to multiply by 3 and then subtract 1. All right, so 1 times 3 is 3. Subtract 1 is 2. So we get that point. E times 3 is 3e. And then when you subtract 1, you get 3e minus 1. And we'll get a decimal approximation for that so that we can plot that point and have an idea where it is. All right, so we know that E is 2.718281828459045, etc., approximately. We'll multiply that by 3, because we have 3e. We subtract 1, we get, this is approximately 7.1, approximately 7.2. All right, so now we have everything we need in order to create our graph. We just have to make the graph itself. So here we go, graph time. Let's do this in red. Red is a color we haven't used yet. All right, so this equation. So let's plot our points. So we've got negative 2, 2, so that would be here. And we've got negative 1, and then approximately 7.2. So negative 1 up here. All right, let's figure out where the asymptote goes. So the asymptote started at the x-axis. With a horizontal shift, nothing changes, because if you have something that is horizontal and you move it left or right, it goes forever. So moving it left or right doesn't change anything. A horizontal asymptote shifted left or right, no difference before and after. It's only when you do something like shifting it up or down that matters. The same thing is true with a stretch. A stretch does not affect something that's sitting on top of the axis. So only the vertical shift down is going to apply to our asymptote. So the new location of our asymptote will be here at negative 1, because it's 0 and then down 1, so then that's negative 1. And so when we connect these together, this gives us the shape of our graph. And so this is our exponential function. So the one on the left is e to the x, and the one on the right is 3e to the x plus 2 power, subtract 1. All right, there we go. That completes this problem.